No matter how you got it, ordered everything separately or as a kit, you must assemble the solder practice shield first. All parts are large, through-hole components, so even a beginner can easily assemble the PCB. But first, what do through-hole and soldering mean? The through-hole parts have metal rods called leads, pins or legs, and we have to insert these into drilled holes in the PCB. We can use these kind of parts with breadboards during prototyping, but breadboards are infamous for being unreliable and the joints easily come apart. Soldering creates durable electrical and mechanical connections between the parts and the PCB traces using molten metal. When this molten metal solidifies, it prevents the part from moving and conducts electricity to close the electrical circuit. But that's enough technical talk, let's see the parts. You will need some resistors. These are surprisingly versatile stuff. In this project, resistors limit the LED current, create a measurable signal for the buttons, limit the transistor's base current, and remove the buzzer's excess charge. These are the most simple and robust parts. Start your soldering journey with soldering all of these because it's almost impossible to destroy them. You will need some LEDs because they emit light, but the polarity is important for these. Install them in the wrong way and they won't work. LEDs have two leads. Out of the box, a new LED's longer leg is the anode and the shorter is the cathode. This is fine, but those legs will be cut at the end, so to keep track of the polarity after cutting the leads, the cathode side is flat. In this PCB, the anode, the positive leg, goes into the left hole and the cathode, the negative leg, goes into the right hole. And buzzers. We can make some noise with these. The left hole is for the positive pin. You will need some tactile switches or buttons. If you press it, electrical contact is made between its leads and it bounces back to the original position when released, cutting off any current. The slide switch is similar. The main difference is it stays in place after switching. The middle pin is connected to the neighboring pin and move the slider to change which pin to connect. You will need a potentiometer or pot for short. Rotating the shaft changes its resistance and the output voltage, which can make analog signals for us to measure. You will need a bipolar junction transistor or BJT2. This acts like an electrically controlled electric valve. And this behavior is used in amplifiers and practically in every modern device. Computer processors are made from these, just much smaller ones. Last but not least, pin headers. These pins connect our PCB to the Arduino after cutting and soldering them in these holes on the sides. This is more than 50 solder joints, so let's get to work. Before you start soldering, what tools do you need? The bare minimum is a soldering iron, preferably with an adjustable temperature. You will need some high-quality solder, like rosin core, not something plumbers use. And flush cutter pliers, because long leads can cause some problems. Of course, you can buy an expensive soldering station with hot air, ultrasonic cleaner, and many more, but let's practice first before buying everything. Let's start with the resistors. They usually come in a strip like this. Just pull each one and don't mind the glue at the end of the pins. If you have bent the lead, that's okay because we will bend it even more. We can't use the resistor with these straight leads, so grab the resistor in your hand and bend the leads down at a right angle with the other hand. It won't break. This way we can insert the component legs in the PCB's holes. Once again, pull one, straighten if bent, 90 degrees, and that's it. The rectangles marked R1, R2, and so on indicate where to put your resistors and how. Only one kind of resistor is used in this for simplicity, so you can't accidentally mix them. Now, insert the resistor leads in the designated holes and push until the resistor sits on the PCB. But the resistor can still escape, so bend the leads once more. Hold the resistor in place with one hand and bend the leads with your other hand. One more time. Leads go into holes. Press the component against the PCB and bend the leads. This way it won't escape during soldering and you don't have to keep it in place, and believe me, you don't want to hold it because it gets hot during soldering. After preparing our first components, let's turn on the soldering iron. If you can, set the temperature to 350 degrees Celsius. Soldering is usually done between 300 to 400 degrees Celsius, but it highly depends on the solder. If you set the temperature too low, it won't melt and make cold joints. If too hot, the flux burns out too fast and the joints will be ugly. But let the soldering iron warm up. When it's ready, get your high quality, preferably rosin core solder and check if the iron is hot enough. Always remove old and apply some fresh solder on your iron tip because solder oxidizes pretty fast and becomes unusable just after a minute. The pros use brass shavings to clean the tip, but the regular soldering sponges are good too. It only needs to be slightly wet. After removing the old solder, apply some on the tip of the iron, place the hot end where the hole and the lead meet, push the solder wire to the lead, and remove the soldering iron. Once again, heat the connection with the soldering iron, apply a tiny amount of solder, and remove the soldering iron. No one forces you to work uncomfortably. Always place the parts in such a way that it's comfortable to work with. Chances are high that your first solder jobs will have some huge solder blobs. There are some standards of how a solder joint should look, but even a beginner can see if it's too much. I use really thin solder wire, but it's easier to overdose regular sized solder. You just have to practice. If the solder ball is not too big, you can remove some excess solder with a freshly cleaned tip. If you think you finished soldering the resistors, cut those long leads. Get your flush cutter pliers, bend the pins one last time, and snap them really near to the PCB. If you don't bend the pins, you will probably scratch the PCB and scratches are ugly. Now, don't stop until all the resistors are soldered. Get one from the strip, fold the leads, put it in place, fasten, pre-tin the tip, heat the joint, apply some solder, and when it wetted the joint, let it cool, and finally snappy. The direction of the resistor doesn't count, but it counts for LEDs. It's important to use the right polarity. The leads are straight and usable out of the box. They just fall right in place, but they fall out as easily. So check the polarity before inserting, hold it in place with one hand, and bend the leads with the other hand. That will keep the LED in place during soldering, and it's the same for LEDs too. Put some solder on the clean tip of the hot soldering iron, heat the joint, and add some solder. But LEDs are much more sensitive devices. They don't tolerate heat as much resistors can do, so please install all resistors before you continue with LEDs. Also, I don't install all the components in this video, just a few for demonstration. When soldering is done, the long leads must be cut, but beware, they can fly far away, so always hold the lead in your hand. Once again, check which lead is longer or which side is flat. Install, press gently, bend the leads, prepare the tip, heat the joint, apply solder, grab each lead, and cut. This way you work with two different types of components. The next part is the buzzer. This one has short pins and can't bend them, and also check the polarity. Some skill is needed to turn the PCB while holding the component in place. Soldering is the same for this too, except we don't need to trim the pins. But the component must stand straight, otherwise it looks weird. So if the buzzer is misaligned after soldering, here's a tip on how to correct it. Gently push the buzzer and reheat the pins. It will pop in place. The next problematic part is the switch. It also has short pins and tends to fall out just like LEDs and the buzzer. But I will show you a trick. Solder only one pin. When the solder solidifies, you can finish the remaining pins without holding the part. Again, you can solder it at a weird angle, but adjusting is much easier if you only have to heat one pin. Oh, and don't forget the stabilizers. They also get super hot, and so does the metal house. Parts can be pretty toasty, so don't just touch stuff, or you may get burnt. The next one is the tactile switch. This button and the potentiometer both have special curved pins. They snap in place and stay there. But if you force it too much, it will bend a pin or two instead of snapping in, so be careful. Position the pins over the holes and push gently. It will stay there and each pin can be conveniently soldered. Always pay attention to the order in which we solder the components. If we had soldered the potentiometer before, It would be very uncomfortable to work with. Start with shorter and smaller components, and leave the big ones for later. Let the transistor come. This is the most challenging component because the pins are near. Its shape helps when you install it. The seal screen drawing shows the orientation. When installed, bend the outermost pins and try soldering. It would be nice to use the smallest tip and add your solder wire really gently, but soldering irons usually come with only one tip, maybe two, and those are usually too big for the job. You will probably short 2 or even 3 pins on your first try, but this mistake can be corrected. A clean tip can take some excess solder, or heat the pins and heat the PCB to remove the excess solder while it's still a liquid. If you have a solder wick, that's great. You can use that too to remove excess solder. And you can also try to add some flux. If you check, I already have some flux residue on my PCB because high quality solder has flux in it. So if you remove the solder blobs, you can retry soldering with some fresh solder and try to be more delicate with the dose. If you add some flux to the joint and reheat it with your soldering iron, shorted connections magically separate because flux increases surface tension and removes metal oxides. This is the wonder of flux. Buy quality stuff, kids. Finally, cut the long leads. The topside's last component is the potentiometer. As I said before, this snaps in two. If it's standing straight, solder all the pins, including the mounting pins. The mounting pins will require a bit more solder than the usual pins. All that's left is the pin headers. You can buy pre-cut pin headers, but this is a practice board. Practice cutting pin headers too. Instead of counting, I usually put the pins directly on the holes and pinch them off on the spot. 6 holes, 6 pins. Easy peasy. If you cut it mid-air, the freshly cut part will usually fly away. Hold both ends. These pins need to be installed on the other side. The previously learned method works here too. Just solder one pin and do the alignment only using this one, because heating 8 to 10 pins at the same time is impossible, and I prefer handling cold pins. Try to make them perpendicular, because these pins will try to fit in an Arduino. Just one tip, try to push the solder on the hole or the pin, not the tip of the soldering iron. If you are ready, double check every joint, correct if you found a mistake, and you will be ready to start programming. The code examples in the GitHub repo are linked in the description, and have fun!